Now, after having a discussion about relations, their types, I would like to tell you what a function is. If you want to understand about the functions, then you must be aware that what a function is. If we have two non-empty sets A and B, or in general if I say you have invited your friends, 4 friends A, B, C, D, and you have put here 4 chairs, chair 1, chair 2, chair 3, chair 4. Here we have two non-empty sets. One, the set of 4 friends, another is the set of 4 chairs where these invitee will seat it. A comes and sit on the first chair, B, C and D. This is a function. So what is a function? It is a relation or an association between two non-empty sets in such a way that every element of first set is uniquely associated with some element of the second set. Function is an association or a relation between two non-empty sets in such a way that every element of first set is uniquely associated with some element in the second set. If we have 7 friends A, B, C, D, E, F, G, 1, 2, 3, 4, 5, 6, 7, and because of some shortage we were in position to arrange only 6 chairs, that is chair 1, 2, 3, 4, 5, 6, and one chair can accommodate only one person. A is with this, B with this, C is mapped by this, D, this is with E, F. There is no place for the last person, last friend, G. In definition, I was telling you function is a relation or an association between two non-empty sets in such a way that every element of first set is uniquely associated with some element in the second set. G is one of the set in the first set. G is the element of the first set, but G is not associated with any of the element in the second set. So what we can say, in this position, in this situation, this will not be considered as a function. In case if I create that chair number 4 is a type, it is a dual, so that it can accommodate 2 persons. If G have got the position to sit, then it will be a function. It may possible that 2 or more elements of the first set can have the same image. We call the elements of the first as pre-image and second are known as elements of the second are known as the image. Another name is the codomain. Another name of the set of first elements of the first set is domain, whereas elements of the second are known as codomain. So it is very much possible that now it is a function, but if G is remained unmapped, unimaged, having no friend, no place to sit, it is not a function. So function is a relation or an association between two non-empty sets in such a way that every element of first set has unique image in the second set. If I create one more situation which I will explain you in the next video. Now I want to tell you one more situation where function is not possible. How? If we have set A or the domain like 1, 2, 3, 4, 5, and in case in this room we have put A, B, C, D, E, F, G, this much number of chairs. 1 is associated with this A, 2, then 3, then 4. As 5, if it is given like this, 5 is associated with E and G both. In this situation also, it is not a function. What reason is after? The reason is very simple, because the word we have used in the definition of the function, that function is a relation or association between two non-empty sets such that every element of first set having unique image, but 5 is having two images. Image of the 5 is E, image of the 5 is G. So this is not a function. So ultimately you must understand, no element of the first set remain unmapped, but any of the element, there may be few extra elements in the second set, that is in the codomain. Number 1, every element must have unique image. 2 or more element can have same image, but same element cannot has the 2 or more images. So it is not a function. If 5 is occupied only with G, then it is a function, though there are 2 elements remained here. So what we can say here, codomain of this function, codomain of the function is A, B, C, D, E, F, G. But all elements are known as codomain of the second set, but only those which are used for imaging, for mapping, are known as the range. Range of the same function will be A, B, C, D and G. So clearly you must understand the difference between the range and codomain. Each element of the second element is known as, each element of the second set is known as the codomain, whereas only those elements which are to be used for mapping, that is known as the range. So difference of codomain and range must be clear, that range is subset of codomain. In case if range and codomain are equal, then some different name is given, which will be explained to you later.